Hey guys, I'm Pat Kelly. Okay, in this problem, they give us our y equals, and they even provide this professionally drawn graph for us already. What they ask us to do is to find that indicated area, the shaded area, and then also to confirm or verify with the graphing utilities. So you might want to have one of those handy. To start though, we are supposed to find that area ourselves, and really that's just kind of trying to tap into hey, do you remember, to find the area under a curve, it's just the integral. So I'm going to start my work by saying, hey, area equals the integral from my lower x value of 0 to my higher value for x of 1, if I'm integrating with respect to x. And then my function that they give me here is 2 over square root 4 minus x squared dx. Conceptually, that's all that's going on. You need to remember the area is just that integral. Okay, so hey, why is that problem in this section of the book? It's because we've just recently learned how to integrate a guy like that. Okay, and this one's actually not too bad at all. Of course, to begin, the 2 doesn't matter. I'm going to end up pulling it all the way out in front. So you're really focusing on the 1 over square root of, let me say it this way, see if it rings a bell. Square root of a squared minus u squared, right? That's the new material. I hope you've learned it well enough by doing the other homework problems before this one that you'd say, hey, that's arc sine. So this is a one-step integration problem, really. The 2 that I mentioned, and then arc sine, parentheses, and if this is a squared, my a is 2. If this is my u squared, my u is x, because the formula we learned has u over a as the argument inside this arc sine. So x over 2. See, that's it in terms of the integration. Now this is a definite integral, so I need to evaluate it from 0 to 1. And even that's not going to be hard. This equals 2 arc sine of 1/2. You'll put my parentheses there and then subtract my arc sine of 0 over 2, 0. Okay, and then here maybe is the new material as well. You have to remember how to evaluate these things, especially if you're doing it without a calculator. You should know how to find these inverse trig functions. 2 arc sine of 1/2, the angle whose sine would be 1/2 is pi over 6, minus arc sine of 0, the angle whose sine is 0, that's just 0. So this is actually just pi over 3, right? All right. We're supposed to verify this with the graphing utilities. So in fact, even before I do that, I'm going to grab a calculator real quickly and find the decimal approximation of that pi over 3. I don't know it off the top of my head. But if I do a pi divided by 3, and I'll just go to maybe 3 decimal places, this approximately equals 1.047. And I'm only doing that because it's going to line up with what my calculator tells me or my graphing utility tells me that we'll do next. Okay. Second half of the directions said to verify your work by using a graphing utility. So grab your graphing utility. I've already got mine. And what you're doing is entering your y equals exactly as it's given to you. They gave you this function. So y sub 1 equals, depending what graphing utility you have, put in 2 divided by square root 4 minus x squared. I'm good. I'm going to graph. And depending on what graphing utility you have, you'll have a different way of finding the actual integral here. Okay, look through your menus. There should be a calculus menu somewhere. I'm going to mine and picking the integration option, my lower limit of 0, my upper limit of 1. So my graphing utility tells me the answer is 1.047. Imagine that. Same thing I got, so that always makes me feel good. That's it for this problem, okay?